Good evening, everyone. We will describe today and explain lesson number 7.4, which is talking about use probability models. Actually, the probability model in general form, we can say that if you write the sample space and the probability of each event, this is called together and collect them together, a probability model. So, probability model can help you to evaluate just the chance, process, and its outcomes. You can develop a model using theoretical or experimental probability by calculating the sample space. So mention what is the sample space is and what is the most favorable outcomes. We will take an example now. A probability model consists of the sample space of an action. Sample space here is the whole outcomes, all possible outcomes. Events, which is the favorable outcomes within a sample space, or probabilities associated with each event. So, as an example, if we're rolling a die like this red one, okay, what is the sample space? Sample space is from 1 to 6. 1, 2, 3, 4, 5, 6. This is all result can be done, okay? So what is the probability of each one of them? As we say before, the whole number always down, which is 6, and the part is up. How many? What is the probability of 1? It's 1 over 6, because 1 appear only one time. What is the probability of 2? 1 over 6. 3, 4, 5, 6, all are equal. Probability, which is 1 over 6. So I write the sample space, then the probability of the samples. This is called probability model. Okay? Okay, so let's take the first example. First example is talking about if you have a jar and you put some marble in this jar. Okay? These marbles are one red marble and 3 green marble and 6 purple marble. Okay, so the sample space may be, if you want to draw one, you close your eye and put your hand and want to choose one randomly. So the sample space should be red, green, 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 purple, 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 purple. So the chance to choose purple is 5. Out of what? The whole number is 10. So purple, 6 over 10. Probability of purple. What is the probability of green? 3 over 10. What is the probability of red? Just one red. So it's 1 over 6. This is how to describe. So we now write the sample space and the events. So this is together called model probability model. Okay. The right one, try to solve it together. Just write does or does not. Okay? Mr. Campbell decided that too many students are getting a pass on homework. He added 10 yellow marbles to the jar. Tell whether each part of the probability model does or does not change. So let's start. After we add to the last jar 10 yellow marble, do you think the sample space does it change or does not it change? Sample space for each one, does it change or does not it change? It does change because the denominator, the whole number will change. So the sample space will change, okay? Because it was before 10, and then I add another 10, it becomes 20. So it does. Each event within the sample space change or not? Yes, change. Does it change too? Why? Because it was 3 over 10, it becomes 3 over 20. Okay? The probability of each event, does it change or does not change? Does it change? Yes? It does change because the probability of green was 3 over 10. Now it's 3 over 20. So it does change. The new probability of drawing a red marble is 1 over 20, not 10, because I add more 10. Okay? Another example, if I have the same jar but with different number of marbles, for red, 11, for blue, 15 for green. If we add them together, we will find them 30. So the whole sample space is 30. And the probability of each one, for red, 4 over 10, 4 over 30. For blue, 11 over 30. For green, 15 over 30. And you can convert it into percent by multiplying each event by 100. So you can get the, as an example, for the red one, it's supposed to be 13.3%, something like this. And so you can calculate the percent for each one. Okay. Another example. Now I had Mrs. Tillman tell her students that the jar contains 100 marble. Based on the table of marble colors after 60 draws, about how many marble of each color are in the jar. It's the same. We will calculate what is the whole amount of marbles. It's, if we add them together, it will be 60. So denominator always 60. Let's calculate the weight of each one. Red, 7, so it's 7 over 60. For blue, 20 over 60. Orange, 1 over 60. And for marble, green, over 60. And as I told you before, I can calculate it. Okay, what about if the number is become 100? This is the amount while it was 60. So if we want to know exactly the number, if it become 100, we will do the following. Equal, let the denominator be 100 and x up. Cross multiplication, so x equal 7 multiply 100 divided 60. It will be about 11.6. So it's about 12 marble, we can say it. So it's about 12, the probability 12 out of 100 means 12 out of 100. This is for the red one. What about the blues? Do the same, equal x over 100. Okay, so it will give you 33%. 33, okay, 0.3, which means if we approximate it, it will be 33 blue, which is 33 over 100. And the orange one, 1 over 60 equals x over 100. So it's equal 1.6, okay, 1.6 out of 100. So it may be 2, we can say 2, because in marble we can take fraction. It must be whole number. And the last is for green, as we did exactly. This is how to compare or predicate what should be happen if we add some marbles and make the number more bigger. Let's solve example number 4. Develop probability model for the spinner shown. Actually, the sample space is S equal the spinner 1, 2, 3, 4, 5. 5 sections. Probability of 1 equals the denominator is 5 and 1 appear only 1, so it's 1 over 5. Comma B of 2 supposed to be 2 over 5. And 1 over 5 too, because it's the 2 appeared only one time. B of 3 appear only one time, so it's 1 over 5. And B of 4, 1 over 5. B of 5 equal 1 over 5 too, because each one appears only one time. This is how to write the probability model, which contains sample space and samples, probability of each sample. Okay. Last. Mr. Henry has a basket full of fruit. He doesn't know how many pieces of fruit are in the basket or the types of fruit. Each of the 20 students in the class select one piece of fruit from the basket without looking, okay? Notes its fruit type and then put it back into the basket. Based on the result shown in the table, what can student conclude about probability of selecting an apple? So this is a sample space. Whole sample space equal 20. If we add them, it will be 20. So denominator will be 20. And sample space. What is the probability of apple? Apple, B, apple. 5 over 20, which means 1 over 4, which is equal to 25%. So the probability of choose apple, that will be what? 25%. What about the next question? The probability model based on the experimental probability for randomly selected. A marble from a bag is P of green is 18 over 40. So the whole number of marbles are 40. 18 of them is green, 14 of them is blue, 8 of them are white. About how many marbles of each color are in the bag is there are 60 total marbles. So I want to predict if the marbles become 60. How to know the number of marbles for maybe here he asked for number of each color for each color. So first one, B of green, which is 18 over 40. Cross multiplication, you will get the number up here, which will x equal 18 multiplied 60 divided 40, 0 is 0. Divided 2 equal 2, divided 2 equal 3, divided 2 equal 1, divided 2 equal 9, which is equal 27 green. And doing the same for blue, and doing the same for white. So you know the probability, you can expect how many marbles it will be after we make the number, the total number is 60. That's it for today. See you next lesson. Bye.